Hello everyone and welcome back to a new Databricks video. A few weeks ago, I spoke at a Databricks event in Prague called Data and AI Summit 2026 Highlights, hosted by Adastra. And the idea behind of the event was very simple: to come back from the Data and AI Summit in San Francisco and share the most important updates with the local community. My session was called Deep Dive AI Agents, and I covered their Genie, AgentBricks, pre-built analytics agents, and custom agent frameworks. Initially, the session was scheduled for 25 minutes, but the questions and the interaction with the audience was so great that we decided to extend it by another 30 minutes. And because of that reaction, I decided to record the demo I showed that night so more people can see it. And in this video, I'll show you how to build a more robust system on Databricks. One that takes a written task in natural language and routes it automatically to either a Genie workspace or to a knowledge assistant, depending on what type of answer actually needs. And at the end, I'll show you how to use an LLM judge to evaluate the answer the system retrieves. So let's get into the demo. All right, so I'm here in my Databricks workspace, and the first thing that I'm going to show you is the data we are going to work with. And the data is coming from financial services and banking institution use case, a use case called anti-money laundering. Let's explore that data a little bit. So for that, I'm going to use this catalog and the schema here. And the table here that is interesting for us is gold transactions. As you can see, all the tables here are in the lakehouse format, but the one that is interesting for us is gold transaction. Let's explore a little bit the content. So we have here at the transaction level, we have the amount, of course, important for us. We have here what kind of transaction type this is. We have the owner of that transaction. Of course, this data is public data set and fictive data. We have the country of origin and the country of destination. And we have a flag here, which is called is fraud. And this is how more or less the data looks like. It's a structured data and it's built on top of lakehouse. We can also go here and explore a little bit the lineage. So we can see the gold transaction here in the middle. And this gold transaction is basically created by combining country coordinates, silver transaction, and banking customers. And then on the right side, we have the consumers of this gold table. Great. Now, the next step, if I want to ask natural language questions about this data, is probably to go here to Genie Agents and create a new Genie workspace, or how it's called now, Genie Agent. I already have one created here. It's called fraud analysis. And now, if we check the sources, then we have here access to these three tables. One of them is gold transaction and a couple of instructions that I gave here. So now let's answer some questions about this data. Let's try with what is the most fraudulent destination country by amount. Let's see if he can get the right answer. The first question might take a little bit longer until the warehouse is started. Now you can see here it's green and we have some answer. So according to this data, Russian Federation is the most fraudulent destination country by transaction amount. And I also have here a diagram, couple of key findings. I can even go here and see the code that he generated from the table. So he picked the right table here. If I want, I can copy this code here and improve it separately, or ask here in the question to improve it. But this is how it works with Genie. Yeah, let's also ask something that is not in the data. For example, who is James Bond? So I'm expecting that he will tell us that he's not able to answer this question because He is just an anti-money laundering assistant who's supposed to respond to different type of questions. Oh, there's no customer agent, so it's searching for a customer. The database contains financial transaction records with customer information. No records matches, so he tried to stay in the context. Okay, great. So this is our agent, Genie agent. But the financial institutions are not only working with structured data. Structured data meaning that can be saved in a structured format, for example, in tables. They work a lot also with PDF files, for example, from regulators, from European Union. A lot of regulation contracts are sitting in PDF files. And if we switch back to catalog, we can go to this catalog and schema. And under volumes, I have several PDF files, which is all relevant to our use case, anti-money laundering. If I go to this one, this is, for example, McKinsey report, why anti-money laundering should be a top priority for financial institutions. And there are a couple of data here, some diagrams, who are the people that contributed to this report, and so on. So this is one of the example. And let's look another one. This is a more challenging one for an LLM, because we have here the title, how agentic AI can change the way banks fight financial crime. And the interesting part is that this PDF file has its text split in two columns. So if we want to process information from this PDF file, how does the agent know that, okay, here I have to stop and then go to the next line instead of continuing on the first line? Because there are two blocks, two columns. And this is one of the challenge, for example. The second one is the hierarchy. So we have a title of the article, then we have a couple of subtitles, then we have some annotation, we have graphic here, more pictures with information, and the text on the right side, which is related to that graphic. So we need to preserve somehow this kind of hierarchy. All right, so we have our unstructured data here. Now, if I go back to my Genie agent and let's take a question, for example, this one here, the answer of this question can be found in that PDF file. But if we try to answer this question in our Genie, it will tell us information not available in the database, which is correct because we gave him access to these tables. Now, how can we solve this problem? How can I have one robust system that can answer questions about my structured data, gold transactions in this case, but also questions about PDF files that I have it there? So how can I have a system in place that can do both? And for the next step, we have to go here to agents and create another agent. The first one that we are going to choose from here is Knowledge Assistant, but you can also have other information. For example, you can build your own custom agent with your custom code, or you can just use this document parsing function, AI parse document, which is very, very interesting because it's extracting structured content from documents, including text, tables, and metadata. So a couple of information, if you go to this documentation, you can find more about this function. And actually, if we are going to choose Knowledge Assistant, this type of assistant is going to use AI parse document as a function. So let's choose this one. That's fine. We are going to give it a name here. I already prepared some names so that we don't have to wait. I'm going to copy the description. So we are going to build a RAG application on top of that PDF files. And in the next step here, after description, I have to point my Knowledge Assistant to a source. So that's why we have here RAG ML, ML schema, dataset, and I have here my PDF files. I'm going to select all and then confirm. The names of these are company documents, for example, a description to the content. And if I want here, it's optional, I can add instructions. I suggest to use these instructions. So do not speculate, make assumption, or provide information outside the provided context. Now these instructions here, be careful, these are not security guardrails. It doesn't mean that the agent will not hallucinate. It's not a security guardrail in place, right? It's just an instruction for the tone that he's going to use. Okay, now we're going to choose create agent. And it will take a couple of minutes until our knowledge assistant is created. Meantime, he is going to synchronize the PDF files, the source data, and we can find here information about our source, about sync progress. So we have here only 5 files. Shouldn't take too long. And once ready, then we can ask him question about that data. All right, so our anti-money laundering assistant is now created. We have synchronized here 5 files. Let's try to ask the same question that we asked Genie before. So according to Interpol, what percentage of global financial crime flows does the financial industry actually detect? And why is this considered a failure despite increasing compliance spending? So we can pose the question here and we have an answer. According to Interpol, the financial industry detects only 2% of global financial crime flows. How do I know that this answer is correct or relevant? Well, you can also go here to sources and verify by yourself. So it pulls out this information from 4 sources. I can even go here and view PDF and it will show me exactly the PDF paragraph where this information is coming from. You can see here the financial industry detects only 2% of global financial crime flows. This is the exact paragraph where he pulled out that information from. I can even go here and check that information, this annotation. Let's try with another question. What are 3 types of AI being applied to financial crime compliance? And how does each one contribute to different KYC and ALM process? Let's put also the question mark here. All right, so I have the answer. Based on the provided documents, there are 3 types of AI being applied to financial crime compliance, each contributing distinctly to KYC and AML. Analytical AI, generative AI, and agentic AI. Where does this information comes from? Again, I can go here and check the exact paragraph where this is coming from. Right? And this is how I interact with this knowledge agent and ask question about my unstructured data. Now let's ask him something that is not in that data. This is auto scope. Something that is related to the financial services, but it is not just in this data set. And it's saying I cannot find information about Swift, GPI, global payment in innovation, transaction tracking standards, or their integration with. So it basically says it cannot find that information in our dataset, which is exactly what we should expect in this case. Now for the people who are a little bit more curious about how this works, when you go here to agent, create new agent and choose knowledge assistant, it's basically a RAG application on Databricks. You can also build it as a code if you want. But what is happening behind, it's creating an endpoint which you can access it from here. And it is also providing here an experiment. So this is the so-called experiment where you can access here observability, traces and sessions, evaluation like LLM Judge, the data sets. You can provide here an evaluation data set with question and expected answer, and then he will basically compare the answer from the inference from the agent with the expected ones, and so on. We have here agent versions. This is where you would monitor in this case. But now something more is happening. If we go to compute, you'll find the same agent also here in AI search. And if we go inside of it, this is actually the vector search index that is happening behind of that. Because this is a RAG application, we follow here the same processes like in the classical one. For example, the chunking strategy, the vector translation, so translating that chunk of text into vectors, into numbers, so that can be interpretable. It is applying maybe the distance, the similarity search, Euclidean distance or Manhattan distance, for example. This all happens behind of this AI knowledge agent. We can even go here. You can see a source table for this sync. So basically, Databricks is creating here Databricks internal catalog. And if we go inside of that, you can find the source table and check exactly how Databricks chunked that data. So he extracted the information from the PDF file and then transformed it in vector search indexes. And if we go to the sample data, we can find here information about our chunks. For example, this one here, this is the first chunk. It belongs to this PDF file. We can find here the parser that he chose, or this AI parse document, the one that I showed you before, this one. And you can find here the chunk size, the chunk overlap. So this is the standard one. This is the chunked text. And this is how the chunk looks like after vectorization. So basically this text here was transformed in this vector search. Of course, what you have seen here, you can also build it as a code and doing the whole RAG application framework within Databricks Workspace in notebooks. All right, so now we have here two things. We have the Genie agent, so fraud analysis, who is basically answering questions about the structured data. But now we also have a RAG application in form of a knowledge agent that can answer questions about our unstructured data in PDF file. But if I ask my knowledge agent something about our structured data, he doesn't have the answer. And the same other way around. If I ask Genie an answer about the PDF file, he doesn't have that information. So how can we combine that into a more robust system? For that, we have to create a third agent, which is called supervisor agent. So this is a multi-agent AI system that combines Genie agents and other agents into one simple system. Let's check how this works. So I'm going to choose this one here, supervisor agent. It comes with this overview here. And I have to choose here the tools or the sub-agents that I'm going to give access to. So this is my supervisor agent. And he's taking as input my Genie agent, which is the fraud analysis. And I'm also going to give him access to my knowledge assistant, which is this one here. All right, so now I have the two of them here. That's great. I'm going to select first the fraud analysis and provide here a description. For that, I'm going to copy the one from the Genie agent. Let's try this one. And for the anti-money laundering system, we already have one. and the instruction that I gave to the supervisor, your anti-money laundering assistant, you use the tools you have access to answer questions about this topic. Do not speculate, respond in clear, professional, and factual format. All right, let's now test our supervisor agent. I'm going to ask him first a question that is relevant for the Genie agent, which is the most fraudulent country by amount and destination country. All right, so I'm expecting that for this question, he is going to choose Genie agent to retrieve that information. Okay, he chose Genie query, and I have some information which is the same. So origin country, Russia, the same that we had before for Genie. Now let's try to answer a question about our unstructured data. So for that, I'm going to choose a question from here again. That was that question with Interpol. The answer with something like 2% or something. So let's try this one. I'll search the anti-money laundering knowledge base for information about Interpol. So now he choose the knowledge assistant query, and is going to anti-money laundering assistant and provide the answer. So more or less the same. The facts are the same. 2% of global financial crime flow. It's coming also from, we can also check the PDF file is the same. And now I have one system that can answer questions about both of them. So if I am asking, let me ask something that is not in the data set. The same one with the SWIFT, Global Payment Innovation. So he chose the knowledge assistant for that. And the final answer is I cannot find information about that because that information is not in our dataset. And this is exactly what we want to happen. So we tested now, we have right now a robust system that can answer question about my structured data, which is coming from the Genie, and also from my knowledge assistant, which is basically a RAG application behind that can answer question about my unstructured data. And this is the role of the supervisor. The role of the supervisor is not to answer the question itself, but to use instead the tools that he has access to and to conform with the instruction that he received from us. And of course you can refine this. This is just a simple example. You can refine this description and this information. The more metadata you gave him, the more context, the more accurate this will be. And from here you can play with it. You can open it in the playground then. So this is the playground. We have the supervisor agent here as an endpoint, together with other endpoints, for example, Queen 3.5, Llama, and so on, Claude, Sonnet, and you can use those endpoints. And now you have your supervised agent as an endpoint and answer a question about that. Now I promise you also that I'm going to show you the LLM judge. For that, we have to go back to our anti-money laundering assistant. Open the experiment. And you can see here again the observability page with evaluation. And under evaluation, you can find here judges. Let's go into this one, create new LLM judge. You have to select the scope. So what actually do you want to evaluate? I'm going to stick with the traces because we have a couple of them already generated. I'm going to select all of them. I'm going to provide a name LLM judge, let's say. And the next step is to select the evaluation criteria. I'm going to choose here retrieval groundedness, which is basically, is the app's response grounded in retrieved information? Let's try to run this judge on top of our traces. And then we can find here per trace what the LLM judge actually thinks. So with regards to the Swift question, which was basically something that he doesn't have in the data set, he's telling that this retrieval was not grounded in our data set, in our retrieval. So that's why it says here no. The response asks about Swift. The retrieved context extensively discuss new technologies. Therefore, the specific details requested in the response are not supported by the retrieved context. Let's check the next one. So this one was with relevant to Interpol. So this was fine. This one was fine. Again, which country has the highest fraud amount? This is a question that answer is coming from the structured data. So Genie should answer that question, not the knowledge assistant. Again, no. Therefore, the claim is not supported by the document, and so on. So you can now go here, create a judge, and the new traces that the knowledge assistant will generate will be evaluated here. All right, and this is how you can create here LLM judge to verify based on your criteria. So this is how you can basically combine Genie, who can answer question about your structured data. I recommend using Genie on top of your gold layer. Don't give access to silver or to the raw layer, because if the data is not well formatted or not curated, then also the answer will not make any sense. And we also created a second agent here for the knowledge assistant, who can answer questions about our PDF files, about data that is coming from that format. And we have a third agent who is basically a supervisor, the pacemaker between those two, right? It is routing the user query to the right agent based on the information that needs to retrieve. I hope this was useful for you. I hope you enjoyed, and until next one, enjoy Databricks.